Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 9, for broadcast on the 29th of January 2020. Coming up on SpaceTime, a new view of the center of the Milky Way Galaxy, Supernova 1987A opening a new window in astronomy, and an 8th target for the Lucy Jovian Trojan asteroid mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have been given a never-before-seen glimpse of the centre of the Milky Way, revealing regions of starbirth and what appears to be an accretion ring of debris surrounding the galaxy's central supermassive black hole. The findings, reported in the Astrophysical Journal, are based on observations taken by SOFIA, the Stratospheric Observatory for Infrared Astronomy, the world's largest airborne telescope, mounted aboard a specially modified Boeing 747 airliner. Astronomers combined data from SOFIA's Faint Objects Infrared camera with previous images taken by NASA's Spitzer Space Telescope and the European Space Agency's Herschel Space Observatory. The result is a stunningly crisp infrared panorama of the centre of the Milky Way Galaxy, spanning more than 600 light-years. The new image has revealed high-resolution details within the dense swirls of gas and dust that make up the galactic centre, opening the door to future research into how massive stars are forming and what's feeding Sagittarius A star, the supermassive black hole at the very heart of the Milky Way Galaxy, some 27,000 light-years away. One of the study's authors, James Radomski from NASA's Ames Research Center in Silicon Valley, California, says the new image is showing our galactic center in detail never seen before. He says studying this region has always been like trying to assemble a jigsaw puzzle with some of the key pieces missing. And the SOFIA data is filling in some of those holes, putting science significantly closer to having a complete picture. The Milky Way central regions have significantly more of the dense molecular gas and dust that are the building blocks of new stars than other parts of the galaxy. Yet there are 10 times fewer massive stars born there than expected. And understanding why this discrepancy exists has been difficult because of all the gas and dust between the Earth and the galactic core getting in the way. But by observing in the infrared, astronomers are able to peer through this gas and dust, illuminating structures indicative of starbirth near the quintuplet cluster, a region with stars 1 million times brighter than the Sun. Among the features coming into focus are the jutting curves of the Arches cluster, which contains the densest concentration of stars in the galaxy. And newly discovered warm material near this cluster could be the seeds for new stars. Seeing these features in high resolution may help scientists explain how some of the most massive stars in our galaxy manage to form so close to each other in a relatively small region and despite the low stellar birth rate in the surrounding space. The new images are also showing material that could be feeding an accretion disk around the galaxy's supermassive black hole. The ring, about 10 light-years in diameter, plays a key role in bringing matter closer to the black hole, where it may eventually be devoured. The origins of this ring has long puzzled scientists because it should have been depleted over time. But the new SOFIA data reveals several structures which could represent new material falling onto the disk, keeping the monster fed. You're listening to SpaceTime. Scientists have managed to peer deeper into the past of supernova 1987A, the first nearby supernova that astronomers have been able to study in modern times. Supernova 1987A marked the explosive death of a spectral type B3 blue supergiant star called Sanderlic 69202 on the outskirts of the Tarantula Nebula, 168,000 light-years away in the Large Magellanic Cloud, a dwarf galaxy orbiting the Milky Way. The progenitor star is estimated to have been around 20 times more massive than the Sun. Light from the supernova event reached Earth in February 1987, making it the closest observed supernova since the invention of the telescope and Kepler supernova, which was visible from Earth in 1604. It gave modern astronomers their first opportunity to study a core collapse Type II supernovae in unprecedented detail, gleaning many new insights into stellar evolution. Now, based on the mass of the progenitor star, 1987A should have produced a super-dense compact stellar corpse called a neutron star. And the neutrino data suggested that a compact object did indeed form at the star's core. However, it wasn't until last year that astronomers were finally able to confirm its existence. That's because it lay hidden, concealed by a thick cloud of cosmic dust. Previously, only the final fraction of 1987A's multi-million-year-long life, about 0.1% or 20,000 years, had been observable. But now, astronomers using the Murchison Wide Field Array Radio Telescope in outback Western Australia have searched some of the lowest radio frequencies available to detect the faintest low-frequency hisses from 1987A. And that's allowed them to paint a picture of the progenitor star's red supergiant phase, millions of years before it went supernova. The findings, reported in the monthly notices of the Royal Astronomical Society, show that the red supergiant was losing mass at a much slower rate than had been predicted, and it had generated slower stellar winds pushing into the surrounding environment than had previously been assumed. The study's lead author, Joseph Culliam from the University of Sydney, says previous studies had focused on material ejected into space when the star was in its final blue supergiant phase. He says just like excavating and studying ancient ruins, which teach archaeologists about the life of past civilizations, his team were able to use low-frequency radio observations as a new window into the star's life. The findings improve science's understanding of the composition of the space in the region surrounding supernova 1987A. Culliam says that allows scientists to go back to their simulations and tweak them to better reconstruct the physics of supernova explosions.
So we've been looking at 1987A at really low radio frequencies, so essentially frequencies you tune your FM radio to, so like 105 megahertz or something like that. And in particular, what we're interested in is the phase of the star's life before it went supernova. And so in particular, my study was very sensitive to the star when it's what's called its red supergiant phase, and that's this phase that our sun will actually kind of go through, where essentially it's run out of hydrogen in its core and it's moved to helium burning in its core, and the outer layers expand up and become red and fluffy and cooler.
You used the Murchison Wide Field Array. That's a different type of radio telescope, isn't it?
Yeah, so the Murchison Wide Field Array is based out in Western Australia, in the Murchison Shire, funnily enough. And it works, as I said, really low radio frequency, so essentially sensitive between 72 and 230 megahertz. This is a precursor to what's called the Square Kilometre Array, so essentially a big radio telescope that the community is invested in building, and it's designed to kind of test the engineering and the science capabilities of that, so as a precursor instrument.
And it looks at a specific bandwidth in the electromagnetic spectrum, doesn't it?
Yeah, so 72 to 230 megahertz, and that's equivalent to when you get in your car and you tune your radio to 105.5 span. You're picking up essentially the frequencies that I'm sensitive to in the Murchison Wide Field Array. But instead of spending all this money to build essentially something that's sensitive just to radio, we build it really far away from people to get away from interference. And so we're sensitive to astronomical objects, and just one of them happens to be 1987A.
And 1987A is an amazing supernova. It's a bit unusual for most supernovae because of the way it's evolved.
Yeah, so it's the closest and brightest supernova to occur since the invention of the telescope, which is kind of amazing to think about. So you can essentially take the telescope was first pointed to the skies by Galileo in about 1600. So not to have a supernova go off except 1987A is pretty crazy, and it just goes to show how important this object is to our understanding of how massive stars and their lives. What we know about the progenitor is it's kind of odd. odder than we ever thought or ever predicted. So the star that actually did go into supernova, all our theories kind of predicted you'd be like a kind of like, if you're about 5 times more massive than the sun, you'll go through kind of a sun-like phase, and then you'd enter this what's called the red supergiant phase, and then you'd eventually supernova. But what we found by looking at archival information of the galaxy of which 87A exploded in, called the Large Magellanic Cloud, we realized that the star actually went through a blue supergiant phase before it exploded, which is kind of odd. We never expected that at all. So why and how are questions that we've been trying to answer.
Red and blue, that's got a lot to do with the temperature of the star itself, doesn't it?
Yes. So red of the star, I know it's kind of funny because in everyday life, we usually mean red to be warm or hot. But for a star, red is actually as cold as you pretty much get. Red is quite a cool star, while blue represents hot. And so your listeners might remember from high school the Bunsen burner. And in particular, they might remember the red safety flame. But if you wanted to use the Bunsen burner, you always turned it on, and the hottest part of the flame was always the blue part of the flame. And this has got to do with black body radiation, but it's not important exactly what it is. It's just the bluer, the hotter, and redder, the cooler. Kind of counterintuitive what we're kind of taught and what we use in everyday language.
When we see the blue supergiant, I guess we're sort of looking deeper into the star to get closer to the core where it's hotter?
We're not quite sure why it went through a blue supergiant phase, and so it's quite hard to figure out and exactly why we saw a blue supergiant before it collapsed. So some thoughts have been maybe it was a binary star system. So there's 2 stars that exist in the system, and one evolved to a red supergiant star. And there might have been something like the sun next to it, and for some reason they merged, they fused together, and in that process, that's quite violent. And that caused it to heat back up and go into this blue supergiant phase again. But it's possible that's maybe not the case at all. Maybe it went through a really weird mass loss scenario. So the star, for some particular reason, lost heaps and heaps and heaps of mass. And so it spewed out and it became blue supergiant again. It was all very odd, and we never expected that at all. And so I can't really tell you the final answer, the reason why it entered the blue supergiant phase, but we know it did. And so we have to change our theories to understand that.
Because 1987A has such a weird hourglass shape, it's not an expanded spherical type shape, could that be telling us something?
Yeah, so the morphology of the supernova remnant is even odd for us, right? So again, we kind of think most supernovae would be roughly spherical, right? You explode a star, it should go out equally in all directions. But for supernova 1987A, as you said, we see this hourglass shape. So it seems tighter at the waist, and then it kind of expands in these 2 rings at the ends. And so people hypothesized maybe that's why, maybe it had to be a binary, right? For example, the binary merged on the equator, and so that's why you have a tight waist, and a lot of the mass loss occurred at the poles. But you also can get that shape if you have a really fast-spinning star, a star that's spinning really quickly, and you get a lot of the ejection from the poles rather than the equator. And so, a lot from the equator as well, from the poles. So it's a very odd shape, and just goes to show 87A is still revolutionizing our way we understand about massive stars and their lives and how supernova occur.
Yeah, a spin-up caused by an increase in mass by 2 stars merging sounds feasible, doesn't it?
Yeah, it's a possibility, and there's been simulations here, and it's one of those questions I don't know if we'll ever know the answer to. We can get close, and there's good suggestions for one or the other, but I don't know if we'll ever know the exact true answer there. What exactly caused it to go to a blue supergiant phase?
That's Joseph Callingham from the University of Sydney. And this is SpaceTime. I'm Stuart Gary. Astronomers have found an 8th target for NASA's Lucy mission to Jupiter's Trojan asteroids. With less than 2 years to go before its launch, scientists using data from NASA's Hubble Space Telescope have discovered a small moon orbiting the Jovian Trojan asteroid Eurybates. Lucy is slated for launch in 2021 on a 12-year, 6.5 billion kilometre long mission. It'll explore the Jovian Trojan asteroids, a population of small ancient bodies which circle the Sun in the same orbit as Jupiter, travelling roughly 60 degrees ahead and 60 degrees behind the gas giant. Lucy will be the first ever mission to visit a Trojan asteroid, and also the first spacecraft to visit 7 asteroids, now 8, in a single mission. Eurybates is considered the largest remnant of a giant collision that occurred billions of years ago, which are thought to have created the Jovian asteroids. Lucy mission principal investigator Hal Leveson from the Southwest Research Institute in San Antonio, Texas, says simulations show that asteroid collisions like the one which made Eurybates and its family often produce small satellites. This correlates with bigger Kuiper Belt objects, thought to be the cousins of the Trojans, which also shows evidence of both massive collisions and small satellites. The Kuiper Belt is a ring of comets, icy debris and frozen worlds circling the Sun out beyond the orbit of Neptune. The new Trojan satellite was discovered as nothing more than a suspicious-looking spot next to an image of Eurybates. Follow-up observations showed the spot wasn't just an optical artifact, but something real, something orbiting around Eurybates. But then things got more confusing. Mission managers ordered 3 more Hubble images in order to try and look at this thing with more detail. But 2 of those observations failed to see anything, raising concerns. Luckily, the 3rd and final image confirmed that this object was real. It really was there. The problem is, this object is really small, just 1/6000th the size of Eurybates, making it difficult to spot. And that implies that it's less than a kilometre wide, which if correct would make it one of the smallest objects ever visited by a spacecraft. While the current data are enough to confirm the existence of the satellite, Lucy scientists will be gathering more data to better understand the object's orbit. You're listening to SpaceTime. Still to come, Dragon passes its final test before manned spaceflights begin. Boeing's Starliner passes inspection following its first spaceflight. And later in the science report, the growing global threat from the new coronavirus coming out of China. All that and more still to come on SpaceTime. NASA and SpaceX have successfully carried out their final major test flight of the Crew Dragon 2 capsule prior to it being cleared to transport crew to the International Space Station. The launch escape demonstration flight of Pad 39A at the Kennedy Space Center involved the deliberate mid-ascent aboard of a Falcon 9 rocket, triggering its capsule to jettison and then safely return to the surface. The launch escape system was activated 90 seconds after liftoff. All major functions, including separation, engine firings, parachute deployment and splashdown, occurred just as planned.
Start up at 1 minute when the computers take over and the launch director go at 30 seconds.
And Falcon 9 is moving into those final stages of the final countdown for the in-flight abort test today. So far, weather's looking okay. We're hoping it's going to continue to cooperate, and the range is green for launch. Again, this is just a test. We're fully expecting Falcon 9 to break up, so don't be alarmed. And with that, let's listen in now.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. Simplify, aim high. Go Falcon, go Dragon.
Vehicle is pitching downrange.
T plus 30 seconds. Falcon 9 with the Crew Dragon capsule is heading east from Pad 39A. Everything looking good right now. As we get ready for max dynamic pressure, we are now throttling down the first stage engines on the Falcon
power
9.
And telemetry nominal.
We're approaching the period of maximum dynamic pressure.
Vehicle is supersonic and passing through maximum dynamic pressure.
You've heard we're supersonic. We're through max Q. We're getting ready now to throttle the engines back up on the first stage.
Stage 1, throttle up.
There's the call out. Okay, the major activity coming up in just over 10 seconds. Shutdown and Dragon escape from the Falcon 9.
Miko. Dragon launch escape initiated.
Dragon's away.
And you can hear some really loud cheering in the room. Bright flash there. It looks like that may be Falcon 9 breaking up. We've got some loud cheers here in Hawthorne. The folks that just watched live the Dragon separate. The next milestone we have coming up at 2 minutes, 25 seconds. We're expecting to see the trunk jettison. So that claw that connects the trunk to the capsule is going to separate, allowing Dragon to separate from the trunk.
And we do have the report. Loss of telemetry from Falcon 9. First stage.
And there's the trunk jettison. Again, some really loud cheers here in Hawthorne, California. This test is looking great so far.
Now the Dragon control system is now going to be reorienting the capsule. We're at a high altitude where the aerodynamics are negligible. So we're going to use the small Draco thrusters on the Dragon capsule to reorient it. That gets it in a position with a heat shield down to re-enter the Earth's atmosphere, and then later to deploy the drogue parachutes.
Now those drogue chutes, we expect to get confirmation that those have deployed at T plus 4 minutes and 48 seconds, so we've got just a little bit of breathing room before we hear that happen. Those parachutes are protected during ascent, on orbit, and re-entry by a panel that's up near the nose cone of the capsule. So we're going to jettison the panel, then the mortars will fire to deploy those 2 drogue chutes at T plus 4 minutes and 48 seconds. Now those drogue chutes, when we see those come out, those will come out before the main parachutes. Those drogue parachutes are what we use to begin to decelerate the Dragon capsule in preparation for splashdown.
We understand we're getting into the drogue deploy envelope on the Dragon capsule.
We expect that will happen when Dragon is at about 20,000 feet. And there they are. Drogue chutes are out. Now we're going to be getting ready for the main chutes to deploy.
Now main chutes will be coming up fairly quickly. There are 4 main parachutes. These are the newest Mark III parachutes. They're each 116 feet in diameter. We deploy them about 2 kilometers above sea level, 6,500 feet above the Atlantic Ocean. Now we're just waiting for the main parachutes to be deployed very shortly. And we have the 4 main parachutes. Now they are deployed in a reefed condition. That means we're keeping them fairly shut to avoid shocks, and now we're slowly opening up the 4 parachutes. Orange and white parachutes as they're opening up into the second position, and then going to fully open. From fully open, we'll be descending about 20 to 25 feet per second down to the Atlantic. So from that 6,500 foot altitude, it's going to take us a few minutes to splash down. Also right now that the mains are out, a sequence is performed on the Dragon, which will reorient the crew seats into a splashdown position, give them a little better angle to take the slow bounce as we hit the ocean. Now, Maria, I talked about the parachutes came out initially at a reef condition. That's fairly standard. They come out not fully open. That way they're minimizing the shock on the parachutes. We're also minimizing the shock on the capsule. Again, we want to give a smooth ride to the crew as they are coming back through the Earth's atmosphere.
Right.
Now, the parachutes are located behind a door that's at the bottom of the capsule. It's below the crew hatch. So Dragon commands the door to release. The drogue parachutes pull the door away, and that pulls the 4 main parachutes out. Now, these are the new Mark III parachutes. We've completed here at SpaceX over 80 tests of that parachute system, including 10 multi-parachute tests of this particular upgraded parachute design over the last few months to demonstrate that the design is ready for flight.
And we're just inside 2 minutes of when we expect to see splashdown. The recovery teams are already out there in the Atlantic Ocean standing by, ready with fast boats to begin their initial approach to Dragon. Again, we mentioned this before, but the recovery operation we expect to take a couple of hours.
I've heard a call out, we're below 500 meters.
And we expect when Dragon splashes down, it's going to be roughly 32 kilometers offshore. So far, all things have appeared to go nominal for this test. All things looking great.
Call out of 100 meters to go.
Now, those 4 parachutes are actually going to be released from the capsule after splashdown, and they'll be recovered too.
And we are down.
Down a little bit early, in fact. Recovery boat beginning to approach instantly. I'm going to try to talk a little bit louder so you can hear me over the folks here. This has been a really exciting thing to see because we had the weather. We weren't really sure if the weather was going to cooperate. We were trying to weigh, is it favorable for launch, but also is it favorable for recovery, because they really have to watch the height of those waves in order to do this operation. There's 4 fast boats out there in the area to begin, again, that initial approach to Dragon. The recovery operation from here takes about 2 hours. All in all, this looked like a really great test.
It looks still a little choppy, so you understand we were kind of on the edge of the weather conditions out in the splashdown area, but they assessed the boat data, the buoy data, looked at the forecast and said we were go. And while we took 2.5 hours to get here, we finally got here and it was great.
NASA's Commercial Crew Program will eventually see both SpaceX Dragon and Boeing CST-100 Starliner capsules transporting crews of up to 7 to and from the International Space Station. Once those operations commence, they'll mark the first time manned spacecraft have launched off American soil since the retirement of the Space Shuttle fleet in 2011. The Crew Dragon 2 capsule is based on the design of the original Dragon capsule used for cargo transport, which was always meant to eventually convey crew. The actual Crew version has been under development since 2014. The capsule uses a new updated outer molding and is equipped with new flight computers, avionics and life support systems. Instead of massive banks of controls, dials, switches and monitors, pilots flying the Crew Dragon 2 will use a simple touchscreen console. The original Dragon cargo ship used 18 Draco hypergolic liquid fuel thrusters using a storable propellant mixture of monomethylhydrazine fuel and nitrogen tetroxide oxidizer. These engines combined the functions of both main propulsive thrusters and a reaction control system for attitude control and maneuvering. The Crew Dragon 2 will be a little different. It'll use 16 side-mounted Draco thrusters, as well as 8 new Super Draco rocket engines, 2 fitted in each of 4 thruster pods. Each Super Draco is about 200 times larger and more powerful than the Draco RCS thrusters. These are designed to provide the escape system to fly the capsule out of harm's way during a launch or ascent emergency, such as the one which had just been tested. But they were also designed for use in orbital maneuvering and originally also as a means of propulsive landings, although that's been put on the back burner for now in favour of parachute splashdowns at sea. Unlike the original Dragon cargo ships, which use deployable solar arrays that are extended once in orbit, the Crew Dragon 2 uses solar panels mounted directly onto the service module hull. The service module, called the trunk by SpaceX, also houses the auxiliary equipment and heat removal radiators, and it has fins to help provide aerodynamic stability during emergency aborts. The new spacecraft also uses a movable ballast sled, which allows more precise attitude control of the spacecraft during atmospheric re-entry. As well as the Crew Dragon 2, a new Cargo Dragon variant capable of carrying 3,307 kilograms of supplies is also being developed to replace the current original Dragon cargo ship. Both the new crew and cargo versions of the Dragon will be designed to remain docked to the space station for up to 210 days at a time. Meanwhile, Boeing says an assessment of the Starliner capsule used for last month's test flight shows the spacecraft survived its journey to space and back with only minimal refurbishment needed before its next flight. The unmanned December 20 test flight, which was planned to travel to the International Space Station, returned early after a computer glitch with its mission clock caused it to miss a crucial orbit insertion burn needed to reach the orbiting outpost. Instead, Starliner was placed in a useless orbit and ordered to return to Earth early, touching down safely at the White Sands Missile Range in New Mexico. Mind you, other than the mission clock computer glitch, everything aboard the spacecraft worked perfectly. Boeing says it's still trying to determine exactly why the mission clock failed, but otherwise the spacecraft will only need minimal refurbishment before it returns to flight. The primary focus will be on the parachute system in the interior of the vehicle. Boeing's still assessing the spacecraft's propulsion, landing and fuel systems. The major physical work will see the removal of the outer shell in order to examine internal components, and the refurbishment of the airbags which are used to soften the landing. It seems none of the tiles will need to be replaced, although the outer shell does show the characteristic burn marks typical of the 3,000-degree temperatures achieved during spacecraft atmospheric re-entry. Boeing hopes to reuse each Starliner capsule up to 10 times. Meanwhile, NASA says its investigation of the mission clock malfunction will last at least 2 more months, but it expects to determine within the next 2 weeks if the next Starliner flight will carry a crew without further unmanned test flights being necessary. Now, speaking of the space station, astronauts aboard the orbiting outpost have carried out their first extravehicular activity, or spacewalk, for the year. The 7-hour 29-minute EVA by Christina Koch and Jessica Meir replaced some of the space station's old nickel-hydrogen batteries with newer, more powerful lithium-ion ones. The batteries are used to store and distribute solar power collected from the orbiting outpost solar arrays. The team also relocated an additional nickel-hydrogen battery pack onto an external pallet in preparation for a future spacewalk. In all, the space station's crew members have now conducted some 225 spacewalks in support of assembly and maintenance of the orbiting laboratory, spending a total of 58 days, 23 hours and 12 minutes working outside the space station. And time now to take a brief look at some of the other stories making news in science this week with a science report. Biosecurity Australia have started screening passengers at airports following the growing threat being posed by the latest coronavirus emanating from China. 2019 nCoV is a new strain not previously identified in humans. It originated in the live animal meat markets in the Chinese city of Wuhan, with animal-to-human transmission through airborne respiratory droplets. Over 1,000 cases of the virus have already been confirmed worldwide, with dozens of fatalities now reported. There is no cure, and medical authorities fear the new strain is mutating as it continues to spread. The World Health Organization says the pathogen's already spread to other Chinese cities, as well as Japan, Thailand, South Korea, Taiwan, Saudi Arabia, and the United States, where the CDC has started biosurveillance at airports. Coronaviruses are a large family of viruses which cause illnesses ranging from the common cold to more severe diseases like Middle East Respiratory Syndrome or MERS, which originated in Saudi Arabia, and SARS, or Severe Acute Respiratory Syndrome, which originated from Guangzhou in China and killed more than 774 people. Associate Professor Adam Camrat-Scott from the University of Sydney says he's concerned that whereas the first cases were traced back to the local Wuhan food markets, the cases in Thailand and Japan apparently didn't visit these sites, suggesting the virus may have achieved human-to-human transmission. According to independent analysis both by NASA and the National Oceanographic and Atmospheric Administration NOAA, Earth's global surface temperatures in 2019 were the second warmest since modern record-keeping began way back in 1880. Globally, 2019 temperatures were second only to those of 2016 and continued the planet's long-term warming trend, the past 5 years having been the warmest in the last 140 years. Over the past year, temperatures were 0.98 degrees Celsius warmer than the 1951 to 1980 average, and over a degree warmer than the average temperatures of the 1880s. The study found that the decade just ended is clearly the warmest decade on record, with every decade since the 1960s being warmer than the one before it. Rising temperatures in the atmosphere and oceans are contributing to continued mass loss in both Greenland and Antarctica, and to increases in some extreme events such as heat waves, wildfires, and intense precipitation variations, with Australia, for example, showing 2019 to be both its warmest and driest year on record. NASA's temperature analysis incorporated surface temperature measurements for more than 20,000 weather stations, ship and buoy-based observations of sea surface temperatures, and temperature measurements from Antarctic research stations. A new study warns that the iconic Australian platypus is on the brink of extinction. A report in the journal Biological Conservation claims action is needed now to minimise the risk of the platypus vanishing due to habitat destruction. Scientists from the University of New South Wales found Australia's devastating drought is having a critical impact on the platypus, with more and more rivers drying up, leaving the mammal stranded. Platypus were once considered widespread across the eastern Australian mainland and Tasmania, although not a lot is known about their distribution or abundance because of the species' secretive and nocturnal nature. Alarmingly, the study estimated that under current climate conditions, and due to land clearing and fragmentation, platypus numbers have now almost halved, leading to the extinction of local populations across about 40% of their range, reflecting ongoing decline since European colonisation. Under predicted climate change, the losses forecast are far greater because of increases in extreme drought frequency and duration, such as the current record-breaking drought. As Iranian-backed terror groups continue firing missiles at coalition forces in the Persian Gulf, another long-time victim of the Islamic Republic's attempts to control the Middle East, the tiny nation of Israel, has announced a major breakthrough in the development of new laser-based anti-missile defense systems. The new technology, which will complement existing anti-missile missile systems, uses electric rather than chemical lasers, making them more efficient. Unlike existing laser weapons, which are mounted on warships or in large aircraft such as jumbo jets, the new IDF lasers are mobile enough to be mounted on armoured vehicles and even flown by drones. A new study claims that while it might seem like culture changes really quickly, in reality it evolves no faster than the animal kingdom. A report in the journal Nature examined recent records detailing changes in popular music, literature, scientific papers, and cars to see how quickly culture evolves, and then compared them with rates of change in the natural world using Darwin's finches, peppered moths, tiger moths, and an English snail as examples. They found that human culture is changing at a similar rate to these animals. And like biological evolution, it doesn't change at random, but rather is shaped by selective forces that can cause stabilization or push it in a particular direction. None of that, however, explains hip-hop. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.